Good evening, everyone. Thank you for joining us to yet another webinar from NSE. Today's webinar is on artificial intelligence and machine learning in finance. This webinar is being organized under the aegis of the NSE ISB Trading Lab. The Trading Lab was set up in 2014 with the aim to pursue research and promote policy dialogues in the area of securities trading, investments, and financial markets. The lab has made significant progress in unexplored research avenues in capital markets, corporate finance, asset pricing, and so forth, and largely focused on the Indian financial markets. The Trading Lab has produced several high-quality research papers, some of which have been published in the top reputed international journals like the RFS, Review of Financial Studies, the Review of Finance, and the Journal of Money, Credit, and Banking. While most of us are familiar with artificial intelligence and machine learning and use these terms interchangeably, they are technically different. AI enables computing systems to perform certain tasks, solve problems, and take decisions like humans. Manufacturing robots, self-driving cars, robo-advisors, and virtual assistants are a few examples of artificial intelligence, AI as we call it. Machine learning, on the other hand, is an application or a branch of AI that enables computing systems or machines to learn from unprecedented amounts of historical data with a level of speed beyond human capabilities and predict output without explicitly being programmed. Today's webinar will help us understand, with the help of some relevant use cases, the driving forces behind the adoption of AI and ML in the field of finance. I would now invite our Managing Director and CEO, Mr. Vikram Limai, to deliver the welcome address and start the day's session. Over to you, Vikram.
Yeah, thanks, Tirthankar, and good evening, everyone, distinguished panelists, Professor Bhagwan Chaudhary and Mr. Hariom Tatsar. A warm welcome to all for today's webinar on artificial intelligence and machine learning in finance. In the modern world, data is an important resource for any organization. Through advancement in technology, organizations can now use their data to gain rich and meaningful insights that can further help them streamline business operations, improve productivity, enhance customer and employee experience, deliver better customer service, and gain competitive advantage. Technology can not only help organizations optimize their operational costs, but also achieve growth and mitigate risks by making them more competitive and agile. Since disruptive technologies have the power to fundamentally transform businesses, adoption of technology is no longer a matter of choice, but a necessity. The financial services industry is rapidly embracing AI and ML in investment analysis, product development, predictive analysis, fraud detection, risk management, process automation, customer service, and many more areas. Access to reliable and affordable connectivity, rising smartphone penetration, and growing ease of operations are making financial services more inclusive, efficient, and personalized. NSE pioneered the digital transformation of India's capital markets and built the first nationwide electronic trading platform based on satellite technology, which elevated the trading experience and operational excellence for investors. Its online real-time market surveillance and risk management system brought in greater efficiency, transparency, and integrity in financial markets. NSE was also the first stock exchange to launch internet trading that allowed investors to trade directly from their homes from any part of the country. NSE has always been a technology-driven exchange and committed towards investing in technologies and initiatives that reinforce risk management, streamline compliance requirements, protect investor interests, and enhance stakeholder experience. AI and machine learning have the potential to drive business innovation, transformation, and client engagement over the next decade. While these technologies can essentially alter the way we live and work, there are certain challenges that can discourage adoption, which include resistance to machines, shortage of right skills, infrastructure and cost of implementation, and poor governance frameworks. The overarching theme of today's webinar is to understand how the AI revolution has transformed financial institutions and enhanced the delivery of financial services globally. We have amongst us highly knowledgeable speakers to help us understand the influence of these path-breaking technologies through their extensive research in this area. On behalf of NSE, once again, I welcome you all to the webinar and hope you find useful and insightful takeaways from today's deliberations. Thank you very much.
Thank you, Vikram. Um, it is my pleasure now to introduce the panelists for our program. I would start with Professor Bhagwan Chaudhary. Professor Chaudhary is a professor of finance at the Indian School of Business and the executive director of Digital Identity Research Institute, a research initiative by the ISB. Professor Chaudhary began his teaching career at UCLA Anderson School in 1988. He has been a visiting professor and lecturer at a variety of institutions, including the University of Chicago, University of Illinois at Chicago, the Hong Kong University of Science and Technology. He has served on the editorial boards of several finance and economic journals, including the Journal of Finance, Review of Financial Studies, the American Economic Review, and the Journal of Political Economy, and has published several papers in the area of international finance, corporate finance, and strategy. His current research interests include microfinance, financial technology, and impact investing. Welcome, Professor Chaudhary.
Thank you, Dr. Dithankar.
Let me take the opportunity to introduce Hariom Tatsat. Hariom currently works as a vice president in the quantitative analytics division at Barclays Investment Bank. He has extensive experience as a quant in the areas of predictive modeling and instrument pricing and risk management in several global investment banks and financial organizations. He's also co-authored a book titled Machine Learning and Data Science Blueprints for Finance, which is an O'Reilly publication, which was published in December 2020. Prior to joining Barclays, he has worked with organizations such as the First Abu Dhabi Bank, the Royal Bank of Scotland, and Nomura, to name a few. Hariom is a BTech from IIT Kharagpur and has an MS in financial engineering from UC Berkeley. Welcome, Hariom.
Thank you very much. Happy to be here.
Professor Chaudhary, over to you, sir.
Thank you, Dr. Mittag. It's a great pleasure to be speaking to this audience. So I'll tell you a secret. I'm called a professor, and most people assume that professor means that I love to teach. Exactly the opposite is true. Doesn't mean I don't like to teach. What it means is that I like to learn new things. And today is one such opportunity for me to learn. So when I was a student, back graduate student days, we didn't talk about AI and ML. We used statistics. We used to call regression and data analysis. But now everybody and his brother is using AI and ML. So there's a lot of jargon there, but there is a method to this madness. And I am delighted to have Hariom with me, who is actually practicing the art of AI and ML in the financial industry. So what we will do is I'm going to let Hariom do the presentation, and I will be a student, which means that I may ask a clarificatory question once in a while to make sure we all understand what is going on. So without further ado, Hariom, please tell us how this AI and ML is being used in the industry.
Thank you very much, Professor Bhagwan. So maybe I'll share a deck, but before that, I'll just mention that people call me quantitative analyst, but I really like to teach. So whenever I get this opportunity, I jump onto this opportunity to like maybe present or teach. So let me share my screen quickly, and then I can walk you guys through what I have for today. You see my screen?
Yes.
Yeah.
Awesome. So yeah, as we already discussed, the topic for today is AI and machine learning in finance. And if you can see on the right-hand side corner, this is the book that I co-authored with two of my batchmates from UC Berkeley. And talking about the agenda, this will answer a couple of questions that you guys had. And also, there are very good points Vikram and Dithankar made. That is what I'll just elaborate on those points. So it's about why and how of machine learning in finance. So the first part is why of machine learning in finance. We have seen this exponential growth, especially in the last couple of years. I'll be talking about that. Why it is needed for financial institutions. That is something I'll be talking about. Why it is needed for industry professionals. That is something I'll be talking about as well. The second part, I'll be talking about some of the use cases. The first part is how AI and machine learning algorithms are used, slightly technical. Then I'll touch upon some use cases in fraud detection in algorithmic trading, how we see the future as well, and I'll have some thought-provoking points here when we think about or we talk about futuristic scenarios. And finally, I'll be talking about adoption of AI and machine learning in finance. Some of the points, barrier to adoption, I heard Vikram talk about it. I will be expanding on that, and I'll also try to give some potential solution that how we can go about adopting it. So let's kick off with this slide of autonomous vehicles. So this is something which is cutting edge in AI. We have heard about autonomous vehicles. Vikram and Mittag also pointed out about this. So what does autonomous vehicles do? What are the features? What are the characteristics? So there are 2 points that stand out. Number one is that it can process and act information in half the time compared to humans. And elaborating on that, it can capture things 1,000 times compared to the human eyes and process the same information in about half the time. So 1,000 times more information and process and act on that information in half the time compared to humans. And of course, it has the potential to automate and disrupt the transportation sector completely. And this analogy applies to finance as well. So when we talk about AI and machine learning in finance, of course, we have seen exponential growth. So there are a lot of quotes and articles we see in the reports that machine learning is going to change. There's a regime change things in finance. There's a regime shift. And I divide the reason for this exponential growth into 2 parts. One is this key AI and machine learning advantage. And the second one is recent innovation that we have seen in AI and machine learning. So this advantage goes back to the autonomous car that I was talking about, where the AI and machine learning can process a lot of data. And when we talk about data, we talk about generally three qualities or three properties of data, which is high volume, multi-dimensional, which means a lot of features, and then multi-variety, which means different types of data, text data and image data or categorical data. So AI and machine learning can process all these kinds of data really, really well compared to the traditional statistical models or statistical methods. That is one of the key advantages. And second one is, of course, it will increase automation and decrease cost. And there are a lot of points which are embedded inside this. People say it will increase efficiency, yes, which efficiency is pretty much increased automation and decreased cost. That is the key AI and machine learning advantage that I would like to link to the autonomous vehicle example that I gave before. And the second one is the recent innovation that we have seen. So there's a significant growth of data. And I was reading this article which says that every year the amount of data that we produce is equivalent to the data which has been produced in the history of humanity. So the growth of data is like exponential. Then affordable computing power, we have cloud-based system, GPU, and all of these are very affordable. It's really fast as of now. And then we have complex AI, machine learning, and deep learning and all these kind of algorithm and the easy implementation. So we earlier, like 10, 20 years back, for something we had to write like 2,000 lines of code that can be done by 1 line of code using all the packages and all the languages and things like that we have today. So this is pretty much. Yeah.
Could I just so the autonomous vehicles is a great example. Many of us still have fears about getting in a car that is not being driven by a human being. Now, you are telling us that there's a big advantage in terms of data processing, 1,000 times as much data in half the time. But why do we have this feeling that, if I left the car to itself, somehow it's more dangerous? What is it that we are missing? Where is this fear coming from?
Yeah, that fear is genuine. And talking about the context of finance, that's genuine because in finance, we have money at stake. We have seen model issues before related to subprime crisis, or we can have flash crash in case model don't work well. So I guess that is one of the disadvantage of machine learning in finance and maybe autonomous car as well. And that's genuine. But at the same time, if you think about it, that for driving a car or for giving a driving license, if you ask that you need to know each and everything about the car, you need to know what's there in the, what's the constituent of the fuel and all, then you will never be able to pass the driving license and you will never be able to drive the car. You will always end up like riding a bike, right? So you need to draw a line somewhere that yes, beyond this point, I'm fine using AI and machine learning. I should not worry, I should not fear quite a lot. And then there can be adoption. That's my take.
Excellent. So I think at this point, I'm going to wait for the rest of your talk, but it seems to me that at this point, we should think about this as in addition to human intelligence and in addition to other forms of learning, we should add AI and ML rather than rely completely on AI and ML. Is that
That's
fair?
a really valid point. So you talked about statistical model. I would say that all these AI and machine learning model can complement those statistical model. They can fill in the gaps of the statistical model rather than using it completely or relying completely on it. We can go gradually, try to fill those gaps and see where it goes.
Excellent. Okay. Please
Okay.
continue.
So we were moving to the next slide, which is about why all these financial institutions should adopt machine learning and AI. So we have seen one company called Ant Financial, which is a fintech firm completely driven by, like it's more or less AI-based fintech firm. If you see the growth or see the market cap, it's close to 150 billion, and that was in 2018, much ahead of the banks, which are like 100 of years old, more than BNP's, Goldman, Morgan, Barclays. And this is the power of AI and machine learning. There is going to be adoption in future, and there was this survey done for many financial institutions all over the world. They've said that they're going to become mass adopters by 2030. And this is something not to scare the traditional banks, but yeah, I mean, in case they don't adopt AI and machine learning, what might happen is they might end up being irrelevant. This is one of the scenarios. This might be one of the scenarios that they might become irrelevant, like Nokia phone, something that happens to Nokia after all these smartphones came. So,
Or they might come back. Let me show you this phone. Anybody know what the brand of this is? It's a Nokia. So some of those people who are disrupted by this may soon realize that they have to come back and adopt this. So maybe that's one of the lessons.
And that happened because Nokia reinvented itself. It didn't
Yes.
stick to the old phone. And that's
Yes.
the message for the banks too. So they need to reinvent themselves.
Yeah.
Okay, so this is for industry professionals. People are really worried that yes, jobs will be gone. What might be the future? It might be true that a lot of jobs will be gone, and we have been reading a lot of articles that yeah, 2020 can be an apocalyptic year for Wall Street. But what might happen is, rather than these jobs going away, these jobs might be displaced. And at the same time, we see quite a lot of articles that jobs in AI, machine learning, all these are growing. And that might be true because what is automation? Automation is pretty much the use of AI. Now, if people will start using AI and machine learning, of course, the jobs will go towards that, and the jobs will be displaced. So what I suspect, or what people say, that a lot of repetitive jobs might go away, and those might be replaced by the jobs which are related to automation, which are related to AI. And that's one of the reasons why industry professionals should try to reinvent themselves and prepare themselves for the displacement of the jobs that might happen in future. Okay, so that was the first part. That was why of machine learning. We're talking about the how of machine learning, how AI, machine learning, data science are being used. So this is something we talked about before. I guess I remember Tirthankar talked about what's the difference between AI, machine learning, and deep learning. So I'll just quickly go through this. These are all buzzwords thrown at us. AI is the superset, machine learning is a subset of AI, deep learning is a subset of machine learning. And when we say data science, there is a good amount of overlap between data science and AI, machine learning, and deep learning, but it's a different field altogether. Think of it like maths and physics. There are a lot of overlap, but they're not exactly essentially the same thing. So AI is something, all the kind of technology or algorithms by which computer replicate human intelligence. We say computer vision. That is something which is trying to replicate our seeing ability. In machine learning, it is a set of algorithm that learns complex patterns in high dimensional space without being directed specifically. Then we have deep learning, where the rule of thumb here is that we use artificial neural network with many layers, generally 3 layers. More than 3 layers is called deep learning. And then we have data science. So all the terms related to data that we hear about, big data, data manipulation, and data management, those basically come under data science. And there's a big overlap. There are a lot of common themes and things we see between data science and AI, machine learning, and deep learning. That's pretty much the difference. Now, just drilling down a bit deeper, what are the different kinds of machine learning? So we have 3 different kinds of machine learning, essentially: supervised, unsupervised, and reinforcement. And there's another kind that we hear quite a lot, natural language processing. So that basically comes more under AI as compared to machine learning. So let's talk about what they are. What are the different use cases? So supervised learning is where we have labeled out whether the price will go up or down, what will be the price of, let's say, Apple tomorrow. And there are 2 kinds of supervised learning, and this is something which is used in finance quite a lot. So one is classification, where we have categorized output, maybe binary output, 0 or 1, or output in form of some category. And then we have regressions, where we have continuous output. So where the classification is used. So classification is one of the most used type of machine learning in finance. The financial use cases are fraud detection, whether a transaction will be fraud or not. Prices will go up or down, which is something used in the trading strategies. And we have credit scoring, whether a person will default or not. So these are like 0 or 1 kind of use cases used extensively in finance. There are a lot of models underlying it, starting from things like logistic regressions and machine learning and deep learning. Then we have regression. In regression, we have continuous output, where we generally use it for prediction. What will be the price tomorrow? That is something used in the trading strategies. And it's also in the US, I've seen the use case of supervised learning in derivative pricing as well. For derivative pricing, we used to have like conventional models, traditional models, but slowly with the growth of data, derivative pricing is also one of the use case of regression. Then we have also.
If I can, I think this slide is probably the most important one today, I think. So let me just spend a little bit of time. So what we are calling supervised in some sense is we are also getting a human judgment. So we are combining 2 things. We are letting data tell the story, but we are helping the data by saying, this is the output. This is what you should put on the y-axis. This is what, is that the right way of thinking about it? That actually there is some more input going on than letting the data itself figure everything out?
You're absolutely right, Professor Bhagwan. So we have something called, in all these kind of cases, we have something called dependent variable and independent variable. So dependent variable is something on the y-axis, as you said, let's say. And there might be a lot of dependent variables or features. So we have to predict y as a function of all the features that we have. So that's what is happening here. And we generally let algorithms decide. There are a lot of algorithms which are highly interpretable. For example, if you use linear regression, you can see all the variables that, for example, let's say for predicting price of Reliance, I'm using the GDP and other stuff, right? So you can see that. But when you're using machine learning, that is where it becomes difficult because you have all these layers and nodes, you get lost. You let machine learning decide, but again, there is a trade-off in terms of simplicity and the accuracy or the complexity that you want to achieve. Generally, for the complex model, you let the algorithm decide all by itself.
Those are all the X variables. I let the data decide which X variables, but my output, whether it's bankrupt or not bankrupt, up or down, that I am feeding to the system. So I am saying, what is it that I'm interested in? And that's where the word supervised comes in, perhaps.
That's right. So when you train, you feed both Y and X. So you feed the machine both Y and X for the historical data, and that is how you build the model. And once the model is built, you use it for prediction. But to answer your question, yes, because you have to feed those Ys or those leveled output for the models to train. And once it's trained, it can do all kinds of prediction. I guess Professor Bhagwan is stuck. So, am I audible or? Hello? Or can somebody just respond if I'm audible? Because I think we have
lost
Hariom,
you're audible.
Okay. Okay. So have we lost Professor Bhagwan?
Yes, I think he is frozen, but I'm sure he'll be joining back in soon.
Okay, then maybe what I can do is, in the interest of some time, I can continue.
Absolutely.
So yeah, I was talking about unsupervised learning. So it is slightly different from what we talked about for supervised learning, and it's in this we don't have labeled output, or Professor Bhagwan was saying we don't have like y-axis, we just have x-axis, and we need to make sense of excess because in finance generally the data is huge, and there are two kinds of sorry, Professor Bhagwan. So you had any other point? I thought of like continuing.
No, I got disconnected for a minute. Yeah, please go.
Okay. Yeah, so I was talking about unsupervised learning where we don't have Y's, we just have X's. We tried, because in finance we have a lot of features or a lot of data. We try to learn pattern, reduce the dimension of the data. And that is where these two types of unsupervised learning come into picture. One is dimensionality reduction and the one is clustering. So in dimensionality reduction, we transform the data to low dimension, try to reduce the noise and redundancy, and then we use it for any financial application. And this is very useful in, let's say, fraud cases, the application of fraud where we have a lot of data. So how do you reduce it? You reduce it using dimensionality reduction. Then we have clustering, where we do the grouping of the data. We group the data using some algorithm, and then we can have a uniform treatment for the entire group rather than treating each and every observation separately. So there are a lot of use cases in segmenting assets or segmenting clients in the homogeneous group in portfolio management. Then we have reinforcement learning, which is something pretty new. You guys might have heard of Go. AlphaGo that was entirely based on reinforcement learning. That was like a machine learning algorithm developed by Google DeepMind, which defeated the grandmasters of game Go. And that is something which is finding use case, or it's being used in finance as well. It's nothing but maximizing your rewards, minimizing your punishment. That is what we generally do in algorithmic trading or hedging. And I've seen a couple of companies here in US, they've started using reinforcement learning. One problem of this is like there is a lot of issues related to interpretability, but this can make things quite autonomous. Then we have NLP, natural language processing. Again, it's being used quite a lot. Chatbots, all the chatbots you see are based on the NLP. Then it's used for sentiment analysis for trading. You get the news, understand the sentiments, and use it for trading strategies. It's also used for document interpretation. So in finance, we have a lot of documents. For example, when you're doing consumer onboarding, then we have things like KYC and all that can be entirely interpreted by NLP, and that can be used and that can decrease the amount of manual intervention and increase the time. So these are the use cases of machine learning. Now coming to the application, and this is something we have seen recently that, I mean, there are a lot of fintech firms. This is the context of India, and we have seen quite a lot of fintech firms growing. Paytm for digital banking, and then Kuvera for wealth management, lending, Craft and all for lending and whatnot. And all these fintech firms essentially, because they have to deal with quite a lot of data, they are in a way or the other using machine learning and AI. So if you look at the left side, talking about the use cases, it's used in algo trading, it's used in digital payments, fraud detection, lending, portfolio management, all these taxes, insurance, market research, and all. And I'll touch upon some of the use cases of AI machine learning in finance, why and where they're used when they're using, let's say, algorithmic trading. So just to give a quick recap of why this is something I talked about in why of machine learning and AI. This is something I talked about when I talked about autonomous cars as well. There are two main advantages. One is AI and machine learning can handle data really well. High dimensional multi-variety of data it can process pretty quickly. And the second one is automation. Decrease the cost and increase more efficiency. So all the use cases or all the financial applications you see would be around these two themes. So first, talking about algo trading, we all know that it's a method of executing orders using automated pre-programmed trading instructions. We use quite a lot of variables. Now there was this survey which was done by Barclays, and it was essentially for US in 2018, and what it said was that AI and machine learning is used by over half of the hedge funds. And it's not just being used, it's also profitable. So there was another report from Preqin which said that AI fund benchmark, which is the benchmark of all the hedge funds which are using AI, outperformed the hedge fund benchmark based on 3 years of cumulative return, and that was in 2018. So it's not just being used, it's profitable as well. Now, talking about the advantages, going to those two themes, data and automation. So first is about data. And trading is about finding that needle in haystack. You have to deal with unstructured data, large volume of data, and wide variety of data, and which is what AI and machine learning is good at. So about 80% of the data that we see is sort of unstructured, and AI and machine learning algorithms really work well on these unstructured data. They're really good in understanding wide variety of data. So be it like text, image, or document. AI and machine learning can understand it, that the typical old statistical models, they can only take like numeric form data, but AI and machine learning can take all forms of data. We talked about unsupervised learning, dimensionality reduction. That is really important, useful, because there is a lot of unstructured data in trading. And then we have an NLP-based model, something that we talked about, take the news sentiments, take the news, convert it into sentiments, and use for trading strategy. That's something which is very useful. And not just looking at the data, but also the complex relationships. So the old statistical model, they were very linear in nature. They could only understand the linear relationship. But all these machine learning models, with their complexity, they can understand the non-linear hierarchical relations pretty well. And that is where they are really useful in trading strategies. Coming to the automation, the first point is trading bot. I was talking about the complete automation. So there are two things, prediction and reinforcement learning. If you remember something we talked about. So AI algorithm can, all these prediction, classification, and regression models, they can predict the market movement. We can have a rules around those prediction and make the trading autonomous. Or we can use reinforcement learning, where we can completely automate. We don't even have to decide or mention the rules. You can completely automate the trading. And once it's automated, of course, the speed will increase. We can have fast trading speed because of AI. One good thing about AI is they can adapt quickly to the changing data. And that is something, again, very important in the financial context, because let's say tomorrow there is a new kind of crisis, something we have not seen before. So new kind of data, and machine learning can adapt really quickly with that new kind of scenario, which is helpful, especially in the algo trading context. And then it will eliminate the human bias. So all these traders have all these biases like overconfidence, fear of missing out, loss aversion, and all. And that can be reduced when we use human bias. There might be some biases because the way we train the model, but the biases probably might be less.
So, Hariom,
This-
that was my question. Since the data is being generated by humans, and we are just fitting patterns to data that's generated by humans, some biases are likely to stay, right? So,
Absolutely.
so there's no machine learning that will eliminate that. But maybe these models can actually tell us about what those biases are. I think that's where the key comes in, that you can quickly learn if there's a bias, we can detect it. So I think that's kind of an important point, that even though it doesn't eliminate all the biases, we might have a better sense by taking a bird eye view of what are the inherited biases that the data is revealing, and maybe we can correct for it.
Absolutely, absolutely, Professor. That's a really good point. Yeah. I can maybe add upon that. So I was talking about AlphaGo, and I was listening to the creators of AlphaGo. What they said was that yes, machine learning, because machine learning models are trained using the human algorithms or the human data at times. So the machine learning models, of course, they had some human biases, but they also came up with those new strategies of playing the game, which didn't have any bias. So it's like combination that might happen, but of course it's supervised learning where we train using the human data. Biases will be there.
Yeah, I'll point out to a paper that's done by my colleague, Prasanna Tantri, who actually finds that some of these things that were trained using machine learning for giving loans out are actually less biased than humans are in terms of giving loans to disadvantaged people and things like that. So it's a very interesting line of research.
Right, makes sense. Yeah, maybe I'll move on. I find this slide pretty interesting. So this is UBS trading floor 2008. We all have this image in our mind of the trading floor, people shouting and asking bid and ask quotes. But what happened in 2016? There were hardly any humans. Everything was replaced by a couple of desks and computers and by very few people. And the future might be something I have on the right hand side, everything being replaced by servers and code, and autonomous trading is there. So this is a probable future that we might have in trading. Moving on to digital payment, we have seen significant growth recently in India because of demonetization, smartphones, e-commerce, internet activities and everything. Billions of transactions worth of trillions of dollars are expected to happen by 2023, and that's something we have seen all around us. What's the advantage? What's the use of AI and machine learning? Going to that broader theme, automation first. So consumer onboarding, you have all these documentation for KYC and whatnot. I've heard some people saying KYC is like kill your customer. But yeah, I mean, all these things can be replaced easily by machine learning or AI. AI can go through the documents, make sense of them, cross-reference the documents with external sources, and make these things easier, much faster. So that is linked to the second point, fast and smooth transaction. While doing the transaction, they can look at the previous transactions, what was the magnitude, whether the person who were making the transaction was genuine or not, and that can speed up the transaction. And then we have AI-based image recognition for going through the document, something we talked about in consumer onboarding. And then we have chatbots, which are being, which use NLP technology for the consumer experience and engagement. And they will become more and more advanced going forward in digital banking space, digital payment space. Again, for security, this is again a big concern. AI, what it can do is it can look at a lot of data. So again, going back to the broad theme of data, it can look at large set of data, monitor and detect pattern and indicate illegal activities, unusual transactions, and it can adapt to things very fast, and it can enhance the security many folds. Talking about the futuristic scenario, this is about the people who are not banked. So if I refer to one of the sources which said that as of now, still after this digitization, 20 crores Indians are not banked, and those are mostly illiterate people. So how AI can help in consumer onboarding, how we can use AI or leverage AI to put more and more people and to, in banking system and open their bank account. So for having a bank account, we need two things basically. Or for consumer onboarding, we need two things. One is contract and one is signature. So all these people who can't read and write, what AI can do, AI has this text to speech algorithm, read the text of the contract, convert it into speech in any language person understands, and read the entire contract. Once the person understands this can be done from a distance. There's no need to like the person-to-person interaction. And once that is done, for the signature, there's something called vocal signature or voice signature, something that is coming up. Every person has its own modulation frequency of the voice, which can be in form of a signature. Once the contract is read, the person can give his or her vocal signature, and for the future transaction, that vocal signature can be used.
Yeah, let me mention here, Hariom, that at DIRI, Digital Identity Research Initiative that we are heading, we are looking at some of these financial inclusion issues. And as you mentioned, precisely voice-related technology is very useful for the clientele that is basically not included right now. For example, just finding out bank balance is a problem. And some of us say, what's the problem? You can just call up a bank and they'll send you a text message. Well, the text message is very hard for most people to read. So we have a project, it's called Bank Balance Batao, in which it takes the text message, takes out the useful information, the bank balance, and reads it out on the phone, even a feature phone. And all it tells you is, so much money is there in your account. Your account has 5,240 rupees, period, in a voice related. So these technologies are coming in very useful, not just for the sophisticated, but in fact, as you rightly pointed out, it can also help the disadvantaged at the bottom of the pyramid. So I'm glad you mentioned that point.
Thanks. Yeah, that's a really good use case as well. And I see that voice is going to be a big thing going forward, all these AI voice-based technology. Moving on quickly, given that we have 15 more minutes, portfolio management is again another use case. We can automate each and every step, and a lot of papers and a lot of reports around it that around 50% of the customers have moved to digital or AI-based portfolio management. Robo-advisor is going to be a big thing going forward. It might hit like close to 150 million with asset under management reaching trillions of dollars because it's cheaper, it's faster, it's using AI. And how it is being used, how AI machine learning is being used in portfolio management. So automation first, of course, going back to the theme. In portfolio allocation, what AI and machine learning can do is it can map the risk appetite of an investor with the market instruments that we have, and then it can perform portfolio allocation, something we have in our book as well. And it can also get rid of the entire questionnaire, the risk appetite questionnaire that portfolio management firms float across to the investors. And it can entirely do machine learning or data-driven based risk appetite analysis. It can be used for goal-based allocation. You say that, okay, after 2 years, I want to go to Paris. What should be in my portfolio as of now? So AI can do that. Or there might be technology to do that. It's used in portfolio surveillance and alert and investment research. You can get alert on the real time using all these NLP. Similarly, natural language processing can go through plethora of documents and give you the key context or key idea for investment research. And investor experience and engagement, of course, chatbots are there to show you what's your portfolio like, what are the instruments in which you should invest, things like that. And futuristic scenario is something I see like this. Going forward, you say to your voice-enabled system, hey, Alexa or Siri, how much should I invest to have $5,000 per month after retirement? And it does all the calculation behind it, all these complex Monte Carlo and machine learning and whatnot, and gives you an answer.
So the interesting thing, Hariom, is that this is the first time the finance theory is being used very actively. So starting with Markowitz, which basically said that, I'll tell you how to do optimization just by looking at the characteristics of risk and return. Now we are saying we can take Markowitz model and fine tune it for each individual's risk appetite. And these requires large amount of calculations, but that's where these methods are really good at. So the finance theory is being put to use in a very creative way here.
Absolutely. That's a great point. Thanks for bringing it up. Okay, I'll quickly move on to fraud. So fraud is something which is adopted quite a lot so far, and this is where machine learning, fraud and credit default or credit scoring is something where machine learning has been used significantly, and about 25% of the venture investing has been in fraud. Why it's relevant? Because when you're doing fraud detection, you have a lot of data, which I already spoke about, can be handled pretty well with machine learning. It can monitor and alert pretty quickly. So AI and machine learning can go through that data and information and detect patterns and alert for illegal activities. It can also deal with unbalanced data pretty well. That is one of the examples I have in the book. So when you go about trying a fraud model, there are very few observations of actual fraud. And there are a lot of non-fraud. So the data is very unbalanced. And that is where machine learning is really useful. It can deal with unbalanced data pretty well. Again, there is one example in the book. So that's how machine learning is used here for dealing with unbalanced data and high volume of data that we see for fraud. Again, futuristic scenario here. As of now, when you get an alert about the fraud, it's on the basis, generally on the basis of location, transaction amount, time. So I'm based out of US. When I go to India, I make a transaction from my US-based account. I get an alert that there is this transaction happening. Now, going forward, what might happen is, so there is a way everybody moves their finger around the smartphone or smart device. And AI has this way to capture the keystroke, pressure, and speed. And that can be one of the digital signature. And if there is any deviation from the recorded keystroke, pressure, or speed, the AI-based algorithm can give you an alert that there is something fishy happening. And that might be one of the use cases of AI machine learning and fraud going forward. Quickly mentioning lending and credit scoring again. One of the area which has adopted AI machine learning quite a lot. There are a lot of success stories in terms of increase in the applicants, approval rate, decrease in the non-performing loans. And these are actually happening as of now. These are not futuristic scenarios. And how it's being used, because one is, of course, data handling. When you talk about lending, you have all forms of data. You have data of zip codes and text data, multi-variety, multi-dimensional, that can be used pretty well or absorbed pretty well by AI. And not just all these traditional parameters, but also parameters, new type of parameters related to consumer behavior or financial history. All these things can be absorbed or taken into consideration by AI models pretty well. I'll be talking about one futuristic scenario and I'll talk about other data forms. And of course, automation is something we talked about, KYC document and targeting the right customer for customer acquisition. And again, it can monitor the risk at each and every step. So for example, somebody has taken the loan and the person has lost the job. So that is something which can be monitored. All these kind of financial and non-financial parameters can be monitored pretty well by AI and can give you alert that, yeah, there's a chance that there's a potential decrease in credit score of a person. Coming to the futuristic scenarios, again, there are a lot of people who don't have credit score in India especially, which makes it difficult for financial institution to give them loans, or which makes it difficult for them to go for loans. So how AI and machine learning can be used? It can be used to get the accurate credit worthiness or credit score of the individuals. And in my use case, there is a farmer who doesn't have a credit score. So generally what will happen to get the credit score, we'll go for the traditional factors like what's the age, what's the wealth, and all these things. These might not be very valid in this context. We need to be more accurate. So for a farmer, what you will do, you will incorporate other factors. So for example, the factors I've mentioned here: size of land, soil fertility, water characteristic, value of crops. And then for affordability, you can see what's the usage of mobile phone, what's the social media usage, travel information of this person and all. And all these can easily be embedded in the machine learning models. There are different forms of data which can be embedded in machine learning models. This is based on advanced features or factors, and the credit worthiness credit score will be more accurate. So this is one of the use case. And so those were the couple of use cases. I think we have established the fact that AI and machine learning is going to be a game changer for finance across all the application in the future. So to quickly touch upon the adoption of AI and machine learning, something that we talked about in the beginning. So these are the 2 points I think Vikram pointed out. Lack of talent and lack of intent are 2 barriers on a very high level when it comes to adoption of machine learning and data science and AI in finance. What I mean by lack of talent is that there's a lot of demand of machine learning, and it's going to grow in future. There are a lot of papers which say that demand can be in millions. We don't have so many people, and even if we have people, the type of machine learning which might be needed for finance is slightly different as compared to something which is needed for computer vision, and that is where the knowledge gaps may be. Then we have lack of intent, like divided into 3 parts. One is inertia. All these traditional banks, they will say that, okay, we have outdated infrastructure, we can't absorb machine learning models, so let's not do it. Then there's this called denial. Disruption is not visible. Yes, I've seen a lot of people saying that, yeah, we are using the same old stuff, like going to ATM, and what's the disruption? There's nothing we can see. Then the third kind is excuse that AI is machine learning and not at all useful in finance. To some extent, AI is black box and not useful in finance. So to some extent, black box feature or black boxing might be true. There is lack of interpretability. But again, if you complement it with the old models, statistical models, there's much you can achieve. So how to overcome these barriers? So there are 2 approaches. One is bottom-up approach that can handle the lack of talent. Where what you say, you go to the workforce, as in junior folks or middle management or the students in the university. You say that, hey, why don't you go through machine learning and data science and finance? You educate and reinvent the workforce. That is something that will reduce the skill gap. And for the lack of talent, a lack of intent, I would say the top-down approach will be more effective, where leaders will step up for the change. And my take would be that the bottom-up approach is more organic, because this is how you train the junior folks or middle management. They can come up with new ideas and go and tell the leaders that, hey, we want to move and adopt machine learning and AI. Why don't you step up for the change? Right? So that is what I'll be talking about in the next 2 slides. Now, the reason for the knowledge gap is something we observed while we were doing project in our university, UC Berkeley, or even while doing the projects that we do at the current work that I'm doing. A couple of gaps when it comes to machine learning and AI in finance. First thing is it's not customized to finance. So what's applicable for computer vision might not be applicable here. Finance is a different use case the couple of points Professor Bhagwan brought up. One is that we need more interpretability. We need to understand, we need to have confidence on the models in finance because there is a lot of money at stake. A small problem can lead to things like subprime crisis and flash crisis. And the second is that there is a lot of noise in the data. The data keeps on changing in finance. It's not a fixed set of data that we have for, let's say, autonomous cars. So these kind of customization need to be taken care of when we are having some kind of course of content related to machine learning and data science. And the second is that there are very few financial use cases other than trading. Read quite a lot of books. Most of the books are focused on trading. A lot of material which are unstructured, people get lost. The material are too theoretical with a lot of equations. Again, you get lost, or they're very too general material. So the solution is just fixing all these gaps. Something which is customized to finance fills the gap related to finance, and it's more focused on financial use cases, all the use cases, not just trading. Something which is more structured, something which is more practical and more which can be applied to the real life rather than just having equations and all. And the overall broader theme should help people reinvent themselves and make the adaptability of AI and machine learning in finance easier. So that was my second last slide. I'll leave you with this takeaway, that not to scare everybody, but yes, this is one of the potential scenario. Machines are coming and we need to reinvent ourselves before it's too late. Thank you. Any questions or any suggestions, any comments, Professor Bhagwan?
Yeah, so referring to your last few slides, I would like this audience to know that we are actually taking a step to fill that knowledge gap. In fact, when I first talked to Hariom and I saw his book, we thought that this is something we should be teaching. So ISB, in collaboration with Talent Sprint, which is a national NSE partner, are going to offer a course starting January of 2022. It's a 22-week long weekends, live virtual seminars followed by async material during the week. And Hariom is going to be an instructor, one of the faculty members, as will I. And also Professor Sanjeev Das, who is at University of Santa Clara, and Anupam Purwar, who is a research scientist at Amazon. So 4 of us are working on this course, putting together this course. We'll be offering from January to June, and we will offer it on a 6-month basis. So we will take those steps to fill this knowledge gap, and it is indeed focused, as Hariom said, on finance applications. So we will go through all of these topics step by step with a little bit of Python programming and applications that are actually being used both in financial service industries and other industries. So please look out for this. The announcement will be coming soon. The course, I think, will be called the Future Ready CFO Program. So watch out for that. Hariom, thank you really very much for this very expansive and comprehensive introduction to AI and ML. And I apologize for tuning in and out because of the Wi-Fi problems, which in some sense is something people worry about even with AI and ML. What if things don't work? Would we need to go back to the old models or not? So at this point, I'm going to give it back to Dr. Tirthankar Patnaik to see if there are any questions from the audience.
Thank you, Professor Chaudhary, and thank you, Hariom, for what was a truly insightful presentation. So much learning. I mean, some of us that have some exposure to machine learning, did end up learning a meaningful amount of new things. So thank you, thanks a lot. And one would obviously, the first question that has come up is, would you be sharing the presentation? So if that could be done, that would be very, very helpful of you.
Yeah, I'm happy to share. There's nothing confidential here, so yes.
Thanks.
That's
Thanks for
that's the wrong, Hariom. You should say, yeah, I'll be selling the presentation.
No, yeah.
Just
Yeah, I mean,
kidding, just kidding.
I'm a technical guy, not much into sales, so.
Well, let me begin with the questions. The first question is a direct question, if I may say so. The question one is, sir, have you implemented any of these AI ML models for your investing and trading strategies? And the second question, a related question is, actually it's not. Can we combine supervised and unsupervised machine learning to create a hybrid model?
Those are really good questions. So the first one, yes, I did, but I'll not like disclose it. But yes, I used AI and machine learning for trading strategies. And the second one, yes, there is one example in the book where I've combined unsupervised and supervised learning. So unsupervised learning is where you reduce the dimensionality of data, and then you feed it into the supervised learning, which is like regression or classification. So rather than taking too many excess, too many features in the supervised learning, you can use unsupervised learning, reduce the number of features, and then again use supervised learning. That what it does, it enhances the speed many folds. And you need to make sure that the accuracy doesn't go down or the quality of the model doesn't go down significantly. But yes, it is something that we have been using as in quite a lot, supervised plus unsupervised.
So one example would be, I mean, when you have too many variables, you use probably principal component analysis or a factor analysis to reduce the number of your dimensions, and then use that into a regression model.
That's right. Given that you're already aware of PCA, I mean, yes, that is what we have done in one of the examples. So there was one Bitcoin trading strategy in which we had close to 150 variables. So we reduced it using PCA to just 10 variables, making sure that they are explaining all the variances in those 150 variables. And then we trained the supervised learning models. The time reduced significantly, and the drop in the performance was not significant and was still giving good trading, good backtesting results. So that is how we use supervised plus unsupervised.
If I may, yeah.
One way to think about this is that anytime you're doing supervised learning, you're helping the model a little bit. So that reduces the amount of computation.
I agree, absolutely. What about interpretation problems? Were the components all decipherable, Hariom?
That's actually $1 million question in finance. So once you switch from simpler models like linear regression to machine learning, the interpretability becomes difficult, right? So there's a trade-off, whether you want to stick to simpler models for more interpretability, or you want to move to machine learning based models because the interpretability goes down. And that's true that people call it like at times black box because lack of interpretability. But having said that, there are a lot of algorithms which are coming up. So all these tech firms, they are working on a lot of interpretability based approaches for machine learning and deep learning. And if we have some robust way, good way of doing that, I think the adoption would be much faster, especially in finance, because there's a great need for interpretability here.
I agree. The next question is, it could probably be answered partly by Professor Chaudhary as well. So the question here is, labeled data is core, as in Hariom's presentation. Labeled data is core to supervised learning algorithms. Given this scenario, why isn't that the Indian financial regulatory system enforces better data quality on the financial markets? Two cases in point here. The Association of Mutual Funds in India does not provide an easy access to time series for daily mutual fund prices. And second one, no listed firm publishes, and this is important, financial statements in XML formats. Just an opinion, not a question. Sir, you're on mute. Professor Chaudhary, you're on mute.
So you're right, data is key. And I think as we provide more and more data, it will benefit everyone. Some of the reasons why firms don't provide data is because they think providing data is like giving away the secrets. And that's where some of the regulatory push might actually help. But the other things are going to be, as Hariom said, as technology becomes easier And as the people begin to understand that, get rid of the fear, I think it'll make it easier for people to share data. And finally, these techniques are very good at dealing with unstructured data. So soon we are going to see data that's messy can actually be organized by these techniques themselves. So we are going to actually see better quality data going forward. Hariom, did you have any thoughts on that?
I think you perfectly answered this, so I'll pass.
Okay.
I just had a related question. Do we see convergence in this case? So, the adherence to AI ML techniques and usage in across countries is very, very different. So I would generally expect US financial statements, for instance, to be available in machine readable formats. And as Professor Chaudhary pointed out, we are quite away, very far away from such a stage. But do you see convergence in this? Do you see, acceleration in terms of such development in countries like India as well?
I agree with your points. I think US is slightly ahead in the game. I've seen a lot of investment banks. There's, for example, JP Morgan has something called coin system. It's using to interpret all the documents, which rather than asking people to understand and go through all these, earlier all these analysts used to go through the documents. That is partially being replaced with something called coin system, and that's happening across the board. There are a lot of applications. For example, I talked about reinforcement learning that's being used here in US. The thing is, yes, India, I would say, in some of the applications, I think it's ahead in the game. Fraud detection and lending, because there is a lot of data in India, and the data is very unstructured. So the complications are even more in India as compared to US. In US, I mean, the data is there. It's easier to interpret them. It's in a fixed format, but the unstructured data is even more in India. So in some of the areas where what I see is that India might be ahead in the game. In some areas like trading and portfolio management, I see that US is ahead, and that's just my take on just looking at the data and looking at the ecosystem. But yeah, going forward, I see if the inertia is less, I talked about that lack of intent. If people understand that, yes, we need to move towards machine learning, it's going to come. If the lack of intent, that barrier is kind of reduced, then I will see the world merging, both the worlds merging together.
You did end your presentation on a scary note, saying don't be left behind.
That is a marketing strategy to promote my book. But yeah, at that point, sorry, go ahead.
So let me just add about convergence. I think market forces will make sure the convergence takes place. We know finance is a great example. Finance is like water, it moves. So if you restrict it at one place, all the activity will move to a place where people are doing a better job. So people will be forced to adopt it. So rather than be a laggard and be forced to do it, you can take a step and be a first mover. And I think that's what Hariom is emphasizing.
Couldn't agree more, sir. Let me go to the next question. This is about the implication of using machine learning and neural networks for valuation of complex financial derivatives. It's a longish question, please bear with me. One of the main purpose of the risk team is to be able to explain the reasons behind movements in P&L. The problem with an NN model is that it's kind of a black box, and if we use it for valuation purposes, it will be very difficult to explain the reasons behind the movements of factors that are most significant. So do you think regulators will agree on using ML models for the valuation of financial derivatives?
Right. So there are a lot of use cases here. One is valuation, other one is hedging, and then other one is all these market risk counterparty credit risk, where we have to process a lot of instruments, value like thousands and millions of instruments overnight, right? So these three are three different things with different requirements. So as in the question, you mentioned that for valuation, yes, we need to understand what's happening in for the different parameters and all. But that might not be the requirement in hedging. In some of the use cases, we need to have faster results. In hedging, a trader wants that, okay, I should be able to quote the hedge to the client as soon as possible, rather than focusing on the accuracy or explainability, right? So in these kind of use cases, machine learning can be used, and they are being used. There are a lot of use cases in hedging. There's a paper recently called Deep Hedging, where machine learning was used for hedging purpose of derivatives. And for complex derivative pricing, there's a company in Canada which won one of the awards for innovative bank or innovative fintech of the year. What they are doing, they're using it for this batch processing. So wherever complex derivatives, they use, like, they're priced using complicated techniques, Monte Carlo takes quite a lot of time, replaced it with machine learning models. So for complex derivatives, they're using machine learning. For simpler, they're using the old conventional models. And overall, they're speeding up the entire processing. So for valuation, yes, I agree with the point that was mentioned in the question, that the explainability might be important, but there are, again, a lot of use cases in which speed is more important than explainability. And that is where it is being used, or it will be used.
Professor Chaudhary, would you like to add something here, sir?
No, so I agree with Hariom that the way to think about this is you don't want to rely only on one thing. Looking at things in a black box will give you patterns, but then when you do take these patterns, you need to go back and build the theory behind it. So I think it's a back and forth between theory and data. That's the way to think about it. So you don't want to leave it completely to data. Data will tell you about things that you had not thought about. Patterns will tell you about patterns that you had not thought, but then you need to go back to square one and say, what is the interpretation? So I think it's the interplay between the two that is going to be more useful.
Thank you. My next question is, again, this is more from a career perspective. Someone's asked, could you dissect the responsibilities and also bring out the differences between a front-end quant at a hedge fund and at an investment bank?
So that is more from, or Professor Bhagwan, do you have anything to add, or should I start?
It's about, they've also asked, I mean, what kind of skills do they really need for?
Okay, yeah. Yeah, so for hedge funds, I think the same skills are needed for both buy side or sell side. Buy side is what you call as like hedge funds, and sell side is what you call as investment banks. So in terms for being a quant, you need to understand programming well, you need to understand maths well. And nowadays, with all these AI and machine learning, there's this requirement of understanding AI and machine learning models pretty well, and their interpretability, right? On top of that, you need to have, of course, good communication, because you need to interact with clients and stuff. So there is all the big portfolio of things that you need to have. There might be slightly different skill set needed for buy side, meaning hedge funds, versus investment bank. In hedge fund, it's more research oriented. So they generally prefer people from PhDs and who have like good background, who are PhDs and people who have a lot of intensive technical background. The investment banks, they don't have that hard criteria as such. Even hedge funds, they are kind of decreasing in terms of rigor they need, the technical rigor they need for being placed into them. But again, there are roles like portfolio management and all in hedge funds, where you don't need so much of technical knowledge. So it depends. I mean, the common skills, the common ground is same. There might be slight differences here and there in terms of what is needed for both buy side versus sell side.
I had one more question actually. You did mention, this is again related to the move towards AI and ML and inducting AI and ML, especially for hedge funds. One of the points you had made, Hariom, was over half of the hedge fund industry actually uses AI ML techniques now. In one of your one of the slides you had mentioned this, and you had also mentioned about generation of alpha. I mean, using these techniques does generate alpha. The question, if I may extrapolate this thought and picturize a situation where AI ML does become all pervasive, do you see results winding down? If it's one technique or one set of techniques being used by everyone, then do you see market efficiency working back, coming back into play?
Yeah, there can be all school of thoughts on this. One point is, of course, everybody is using machine learning. The profits are kind of will die down because everybody is using the same kind of techniques. But at the same time, what might happen is, and that's my take, and I'm kind of optimist. So I go to again this AlphaGo example where the algorithm came with new strategies. It didn't only replicate the old strategy, it also came with new strategies, which were never known to humans, which were never known to all these great players. So that might be one of the scenario where if you train the machine learning well, if you make it like use things like reinforcement learning and all, it might come with new kind of strategies. You don't know what's happening in the, because the data is huge in financial world. There can be different ways of finding that needle in haystack, and machine learning may be able to do that well. And if let's say there's a hedge fund who is able to train these things well, they are able to generate alpha in spite of everybody using machine learning.
I see. So, I mean, the differentiation will be in how well they use it or what kind of techniques and results hitherto, unforeseen.
Yeah, that's happening as of now for statistical model, right? So, for example, we have Renaissance technology, right?
Yes.
They're using statistical model, but they are generating 60% return since last 10, 15, or 20 years, right? So that might happen in AI as well.
My last question for this webinar is to Professor Chaudhary. Sir, when does AI ML become mainstream? I mean, you did mention a program that ISB will run with Talent Spring. There are, it's an NSE firm, and there is, there would be, I would imagine, significant amount of interest for the value, people would expect from such a program. But in terms of educational institutions, when do you think coaching becomes teaching and then becomes a degree? There are several degrees before you say. I mean, I'm aware of the fact that there are several graduate degrees already being offered in the area of machine learning. But when do you really see it becoming absolutely mainstream? This is important, and people will not be able to do anything without it from an educational perspective. I think we'll wait for Professor Chaudhary to be back. Hariom, what are your views on this?
So if I understand the question correctly, it was when it will penetrate completely in education?
Yes.
It's actually happening. I mean, I don't see, so you take my example, I was a traditional quant like 5 years back. I was working on all these Monte Carlo and all these old valuation models. I switched to machine learning models, and I see that adoption is happening big time. So even the all these universities, they're coming up with courses in fintech and AI, and they're replacing all these traditional courses with fintech, AI, machine learning courses. So it's happening. I'm not sure about the full transformation or full like complete overhaul. It might take some time. There'll be some time for the next, I guess, 5 to 10 years. Both will be used parallelly. Slowly, machine learning will increase, and then it will take over. So I would, if you ask me the timeline, I would say 10 years.
Professor Chaudhary, would you be more optimistic? Hariom, could we indulge you for a few more questions?
Sure, I can take 2 more, but I have a meeting at 9:30 here, so I can take a couple of questions more. That's fine.
So this is from Sanjeev Das. He'll be taking one of the courses. Yeah. So the question is, why has India decided to underinvest in AI when China has gone all in? Yes, there are privacy issues that are ignored in China, especially for finance and credit applications. But India can also make a trade-off between privacy and financial inclusion. Where do you see the government's investment going in this area?
I'll let Professor Bhagwan comment on that, because he might be more knowledgeable about it.
Keep getting disconnected. My deepest apologies. I think, as I said, this will be forced by market forces, not by governments. And In terms of when would universities start to do it, the answer is now. It is happening now. By the year 2025, nobody would be asking this question anymore. Then why are we not teaching AI and ML? In fact, you will not hire a CFO who doesn't understand these things. That's my prediction by 2025. When you say, why is India not investing in AI? I would say, forget the government. Don't rely on the government. Let the private sector take the lead. I think that's the way progress has happened in the West. That's the way the progress will happen in India too. As long as there are market forces, this is bound to come. So I would not, I'm fairly optimistic that things are going to look a lot different in 4 or 5 years.
I would tend to agree, Professor Chaudhary. I mean, I would basically compare AI and ML with the early 90s advent of IT services companies in the country. Not so much support by the government, but these companies did do fairly well, and they gained significant amount of market share. And 3 decades later, they're still there, and they are a force to be reckoned with. One more question, last question, Hariom. Gentlemen, does any aspect of AI ML scare you? Do you expect cybers to emerge with ability to do unstructured work in the near future?
That's an interesting question. I'll not go to the extent of all what we see in the sci-fi movies. I'll just stick to finance. So yes, interpretability is one of the issue. I talked about it again and again. So we have seen models not behaving well, has led to big things like flash crash and even subprime crash. The CDO model didn't do well right there. So if we don't understand the models well, especially all these AI and machine learning models, and there is lack of interpretability around it, we blindly throw it and use it for different use cases, then let's think about the fact that there's a hedge fund who's using AI-based model, not understanding anything, buying and selling, and all of a sudden it leads to flash crash, which crashes the stock market, same as what happened during the flash crash. Right? These kind of scenarios might be there if we don't understand the models well. And that's why I feel that interpretability is really important. A lot of research work, as I said, is going. Even I'm working on a couple of them. But that's the demand, but that's the key requirement, especially in finances of now. And that is where I talked about the customization of the courses for finance as well. There I talked about interpretability. That is the fear I have. Like people don't understand models well, just implement it, use it, and that it causes a lot of chaos in financial market.
I would agree. I mean, this is where the role of regulation becomes more and more important, because these can become serious weapons, so to speak. But my last question in this presentation, and it is something to do with teaching, Hariom and Professor Chaudhary. So it comes from a teacher, one of my friends, Amol Agarwal. He asks, for a teacher of economics and finance like myself, your presentation is scary. The pace of AI ML in industry is really quick, but in academia, things are not really as quick. Moreover, academia is also highly fragmented, and well-endowed schools can pick these skills quickly compared to not so well-endowed schools. How can academia learn these skills at a faster pace so we can serve the industry better? Do we see AI ML robots doing a better job of teaching finance in the future, as they can learn so much quickly? Professor Chaudhary?
I think it'll be both. So I think the hybrid model is already here. So you don't need to have a model in which you sit under a tree and learn from the guru. So I think there will be a hybrid model. So you will see online courses, hybrid courses, but you will also see a role of professors like me to tell you what is important and what is not. So think about it as textbook. When textbooks came, what happened? It didn't make the role of teachers defunct. Teachers were still required to take the textbook to tell you what to pay attention to and what not to. But it really expanded the reach of the knowledge. And I think the same thing is going to happen here. With all the technology, the reach of knowledge is going to increase, but you will still need wisdom. You still need somebody to tell you, trust me, this works and this doesn't work. So I am not as scared as you are. I think our jobs are still safe.
our jobs are still safe. And on that positive note, let me bring this exhilarating webinar to a close. I thank Hariom Tatsat. I thank Professor Bhagwan Chaudhary for sharing their time with us and sharing so many insights with us and taking the time to answer all our questions. I thank Vikram Limai, our Managing Director and CEO, for this webinar. And I also thank our marketing team, Saurabh Mehta. And ladies and gentlemen, have a nice evening. Thank you.